So what we're going to be using here is the Fluke Model 744 documenting process calibrator to simulate a Type J thermocouple into this Rosemount 644 temperature transmitter. To do this, the Fluke is going to do some extra little magic for us. When we type in a number for temperature, like 200 degrees Fahrenheit, it's going to not only look up in the thermocouple table how many millivolts that would be equivalent to, but it's also going to subtract the amount of voltage necessary to outsmart the compensation built inside this transmitter. For example, let's start with our number of 200 degrees Fahrenheit. 200 degrees Fahrenheit, Type J. If we go down to our thermocouple table, and we see here, let's move this down. There we go. Okay, sorry about that. 200 degrees right here, Type J thermocouple, degrees Fahrenheit. We have 4.907 millivolts. So 4.907 millivolts is the equivalent millivoltage for 200 degrees Fahrenheit Type J thermocouple with a reference junction at 32 degrees Fahrenheit. We do not have a reference junction at 32 degrees Fahrenheit. We have a reference junction essentially at room temp. Looking up here, you can see how many millivolts it's actually putting out. It's not putting out 4.907, it's putting out 3.646. You might be wondering, where does that number come from? Well, here's where it comes from. The Fluke also measures ambient temperature, in this case 76.4 degrees Fahrenheit. And that is the same ambient temperature being detected by the compensation circuit inside the transmitter. Remember, the purpose of the compensation circuit is to add an additional millivoltage to the thermocouple signal to overcome or to cancel out the natural reference junction voltage produced there when the thermocouple wire is attached to the transmitter terminals. However, in this test setup, we don't actually have a real thermocouple connected, even though we are using thermocouple wire, because these two junctions at the Fluke and there are at the same temperature. They basically cancel. We could be using copper wire and pretty much have the same situation. What that means then is the compensation built into that transmitter at this point in time is not performing a useful function. It's trying to compensate for something that isn't there. So it is adding an additional millivoltage that we don't need to be there. So the Fluke is aware of this. The Fluke knows this. And what that means is it's going to calculate the amount of millivoltage based on the table for 200 degrees Fahrenheit, which we saw was 4.907 millivolts, and subtract from the 4.907 the amount of millivolts that it knows the compensation circuit is generating. Therefore, when it outputs that millivoltage signal and the compensation adds the additional in there, it's going to read 200 degrees Fahrenheit. So let me show you with real numbers how this works. We've already seen 200 degrees Fahrenheit, looking at our table here, is 4.907 millivolts. So I'm going to take 4.907 on the calculator, and from that I need to subtract the millivoltage that is going to be equivalent to ambient room temperature, because that is what the compensation in the transmitter is automatically adding to the signal. So to do that, we look at the ambient temperature, 76.4 degrees. If I go back to my table and look up 76.4, here's 70, 71, 72, 73, 74, 75, 76, 77. So somewhere between those two is what I'm shooting for. Just doing the estimation in my head, those are 28 millivolts apart. Half of 28 is 14. Adding 14 to that, I get 1.263. So I'm going to subtract 1.263. And so my Fluke needs to output 3.644 millivolts for this to work. Sure enough, 3.647. I may have done a math error in my head. I may have interpolated incorrectly, but oh yeah, I'm not exactly 76.5, I'm 76.4. So you can see here what I've calculated on my calculator and what the Fluke is putting out is very, very close to being the same. The Fluke knows that the compensation circuit in the transmitter is active, therefore it knows it has to output just a little bit less than the ideal 4.907 millivolts to make this transmitter see 200 degrees Fahrenheit. Because in real life, if we had a real thermocouple connected to the input of this transmitter, the measurement junction would be creating 4.907 millivolts, and the reference junction would be taking away 1.263, and that's exactly what the compensation circuit's re-adding in there. So we have to outsmart the compensator, and the Fluke does that for us.